Okay.
So I'm sharing my topics list. In the previous session, what we have covered is we have covered system and user defined routes. Then we covered Azure private endpoints and Azure service endpoints. This is what we covered in the last session. So today's plan is to cover application gateways and load balancer. And tomorrow we'll be covering a front door, traffic manager, and network watcher. So with these topics, we'll be done with the networking part. Later on, we'll start with Azure Virtual Machine scale sets. Then we'll move on with the Key Vault, container registries, and so on. So most probably
Sure.
in 5 to 6 sessions, we'll be closing this Azure Virtual Machine, Azure topics.
Azure part. Yeah.
Yeah. So we'll begin with load balancer. So load balancer here on Azure, it works same as how we configure in on-premise. It works at layer 4, that is the transport layer of OSI model, and it acts as a single point of contact for all the client requests. So whatever the whoever are trying to access their application which are hosted in these virtual machines, or whatever the data is hosted in these machines, and they have to go through this load balancer. And what load balancer does is it will distribute the inbound traffic. It will distribute the inbound traffic, whatever is coming or hitting the front end, and it it forwards those requests to the backend pool or the backend pool instances. So uses load balancing rules and health probes to manage traffic flow. So I'll explain you with an example what is load balancing rule and where do we use these health probes in the coming slide. And here in backend pool, it will include virtual machines or virtual machine scale set. So virtual machine scale set is nothing but a bunch of instances, like the same virtual machine with the same configuration. So those are easily scalable. Like we can scale in and scale out. Like I want to increase it to 4 instances, you can increase it to 4 from 2 or 1, but the configuration and everything will be identical. And it ensures high availability and efficient traffic distribution across resources. So load balancer takes care of high availability and efficient traffic distribution. So next is the load balancing rule. So this is one important thing which we will be configuring where when we configure this load balancer. So load balancing rule will have these components, like it will have a front end port and the back end port. So it will have a front end port and the back end port. So that the front end port will take the request and back end port will forward those requests to the back end pool. So the back end pool, what it does, it has a group of servers. It has VM1, VM2, VM3. Like that, there will be instances in the backend pool. And protocol and health probes are two other components which will help for communication. And health probe is something which makes sure that the backend instances or the backend pool, whatever the servers are there, they are up and running. So what it does is health probe. It keeps on sending one packet to check if the backend servers are up and running. If there is no response, then it tries for a few times, then it will stop forwarding the request to the backend server. So here is one example. Showyes.com is one website where the consumers are trying to do the shopping. So they hit this website, and so users are trying to access the website on port 80. So they are entering through port 80, and the requests are going through load balancer, and they are coming out at 8080, and they are going to VMs. The same way slash health uses um, is used for checking the health of the endpoints, and load balancer distributes the traffic evenly among healthy VMs. The flow is like this, it starts at front end port and goes to the load balancer and it goes to the back end ports on VM1, VM2, VM3 on port 8080. So this is Health Probe in action. What it does, Health Probe continuously checks each VM status. So it will check the VM status continuously. It starts sending the ping packet or heartbeat every 5 seconds or so, depending on the configuration we configure in the load balancing health probe. And if a VM fails health check, it's temporarily removed from the rotation. As I said earlier, if the VM stops responding, it will stop sending the traffic to that VM. So, and also the load balancer makes sure that the VM is removed from that backend pool. And once this load balancer keep on sending the hits, heartbeats to that. Once it starts responding, it automatically adds the server back to the backend pool. So, and load balancer makes sure that the only healthy servers are there in the backend pool and they are handling these user requests. So here is one example, the restaurant example. So we'll compare the back end port with this example. So what is happening? So you are going to a restaurant and you are placing on order. Okay. So restaurant entrance is nothing but front end. In the back end pool are chefs in the kitchen. So the chefs in the kitchen are back end pool who are preparing your order. And backend port is chef's workstation. Backend port is chef's workstation. So actually the chefs will be preparing your dish in the kitchen, right? So chef's workstation is kitchen room or the chef's workstation. Okay, protocol is TCP or UDP. So type of service like reliable dine-in. So you are going and eating there or you are taking a takeaway. So here TCP and UDP are the protocols which make sure the requests are going. So this transmission control protocol is something, what happens, you send a request packet and it is going from the load balancer to the VM. And suppose if there is one packet which is having some data, like the user is trying to access the Facebook website. And here the website is and the request VM1 is responding to your request. Okay, and it is unable to download one of the picture. What happens? The load balancer, which is using TCP, it tells I did not receive ICMP packet. Basically, this VM1, when you are using TCP, it will acknowledge the request with ICMP packet, Internet Control Messaging Protocol. It controls the it controls the this controls the whatever the data is there. If some packet is dropped, it will say, I did not receive this packet 4 or packet 5. This load balancer will tell this VM, and this VM will send that packet 4 or packet 5 back. That is nothing but a image or something. So that is TCP. Whereas UDP works in a different way. Like UDP, for example, a VoIP call. Okay. So you are making call from US to India. Okay. And there is a break happening, like one of the packet is dropped and you are not able to understand what the other person is saying. And this UDP protocol will not acknowledge that there is one packet dropped and it will not resend. If it resend, it's like, it is jumbled. The voice will come, the words will be like jumbled. So UDP is protocol used in VoIP and it does not acknowledge that the packet is received or not. Okay, so these are the two different types of services or protocols. So TCP and UDP, these are used. One will acknowledge that the packet is received. One will not acknowledge whether the packet is received or not. The TCP will send if the acknowledgement is not coming, TCP will send the packet again. UDP will not take the acknowledgement or it will not resend any packets. That is a major difference. And this is the type of service it uses. Okay, so this is about the kind of service or the packet forwarding technology, I will say. So that's how the load balancer and VMs respond to each other. And health probe is one thing, as we covered in the previous slide. It keeps on checking whether the VMs are up and running. And manager checks. Here the manager is checking if chefs are ready. In this restaurant example, manager is checking whether the chefs are ready, and whatever the order he has taken, he makes sure that whoever whoever is ready, he is taking your order to them and getting that prepared. So that is a
Got it.
yeah, that is a real life analogy restaurant example. So the takeaways are like this. Load balancing rules define traffic direction and behavior. Ports connect users front end to the back end. Protocol ensures proper communication is there between the VM and load balancer. Health probes keep traffic going only to healthy VMs and helps achieve scalability, reliability, and fault tolerance. So there are quick labs. Okay, so today we'll be doing lab on application gateway. This is a traditional load balancer, and so I will share this slides. I will put this in one of the drive. I have created one drive actually. I will
Okay.
go ahead and share the link. Mm, my files. Yeah, I will share this link. Today
Okay.
I will make sure that I share this link, and I will keep everything from here to here, and I will share.
Okay.
So the next topic is application gateway, and so we have a lab also for that. Mm, So the load balancer was working on layer 4, that is a transport layer. But here, this Azure application gateway. So this is the intelligent web traffic load balancer. So web traffic load balancer. That means it works on application layer, that is layer 7. So it is a web traffic layer 7 load balancer in Azure, manages and distributes HTTP, HTTPS traffic to web application, works at application layer. Unlike traditional load balancer layer 4, it can make content-based routing decisions. So I will explain you in the next slide what this content-based routing decision means. Uh, okay, before that, let's compare traditional load balancer with application gateway. Traditional load balancer, it works at layer 4 and this works at layer 7. And routing is basis on IP address and ports. Here, HTTP request content. And here the protocol is in load balancer, the protocol is TCP UDP, whereas application gateway protocol is HTTP HTTPS. And the example is forwards all traffic to backend pool. It will forward traffic based on URL or host name. So how it works? So if you see this example, so someone is trying to access contoso.com. So the request is going through application gateway. So it has a front end IP, one public IP. This contoso.com is hitting that. Then it is going through application gateway. The application gateway has two pools, two backend pools. The first backend pool name is image server pool. The second backend pool name is video server pool. And how it works, the application gateway, it will check what is the URL. If the URL is looking something like this, site.com/images, the URL is looking like this, /images, then it will route the request to image server pool. If the URL is looking like /videos, then it will route the request to the video server pool. So as this is working at layer 7 application layer, so the URL based routing is shown here with an example. Okay, you host both images and videos on your web application. /images goes to pool A, /videos goes to pool B. So this is URL based routing. So here is one example how it works. Okay, so you are in an airport uh, and you went to information desk. So and direct passengers based on destination. So there are two terminals. One is an international terminal. The other one is a domestic terminal. You are not sure where is domestic terminal and where is international terminal. You just have your ticket and you have shown that to the in, you know uh, to the person who is at the help desk. So they will direct you where to go. You whether you have to go to the international terminal or the domestic terminal. So what is happening here? A passengers are being directed to different terminals. Here is that example. So imagine an airport information desk directs passengers based on destination, like URL path here. Images, for example, images equal to domestic terminal, the pool A. Videos equal to international terminal, pool B. So it ensures each traveler request reaches the correct gate. Here it is server or the pool. Any questions or anything?
No.
So the key takeaways from here is the application to gateway works at layer 7. That is an important thing you should remember, and makes intelligent routing decision and provides security, scalability, and optimization, and ideal for modern web application. Even in our organization, we are using application gateway for forwarding the traffic. I mean, for hosting our applications. The front end is app gateway, and it is taking the request and it forwards to the backend pools. Instead
Okay.
of servers, we are using app services here,
Absolutely.
and yeah, app service, and also for one project we are using Kubernetes. The backend pools are Kubernetes.
Okay.
So what are the components of application gateway? Front-end IP configuration, where incoming traffic lands first, public or private IP. Users access here myapp.com, which is a public IP. The next component is listener, detects traffic on a specific port and protocol, listens on port 80 and 443. Rule defines what to do with the traffic received by the listener, route traffic based on path or host. So these rules we will configure so that it helps us to understand from where you are taking the request and from where to where you are forwarding. So the rule will configure that.
Okay.
The backend pool is nothing but group of servers or app services or Kubernetes or whatever it is. Backend HTTP setting. So this will define uh, how the gateway talks to the backend server, like the which protocol it has to use and which port it has to go out or go into this backend server. Cookie setting, all these things are in the backend HTTP setting. Health probe is again, it works same like how it is in load balancer. It checks if the backend instances are healthy. If it is not healthy, it will remove from, um, it will stop forwarding the request to the backend pool or to that
Okay.
instance. How these components bind together. Front-end IP will receive traffic from user, listens for requests. Listener will listen the request. Front-end IP, it will it will take the request, and listener will listens to the request which are coming from the front-end IP, and it makes sure that the port and certificates are the binding are done, and the listener will have the rules. So the rules are something which will determine to send that request. So rules will make sure that it has to forward the request to so and so, like to which pool it has to send. And the backend HTTP setting, as I said earlier, protocol, port, and everything will be there. And health probes, as I said earlier. So here, let's see. You have a website. This is so if you are typing this UI, web UI. it goes to the home first. Then if you are trying to open images, you have to, slash images will go to the images pool, videos will go to the videos pool. You want to route requests based on URL path to different server pools here. Front end example is also, sorry, this airport information desk example. Again, it is trying to say which component is what. Front end IP here it is airport entrance where passengers arrive. So front end IP is airport entrance where passengers arrive. Listener is receptionist listening for destinations. Rule is decides which terminal or gate to direct passengers to. So rule is nothing but it will. So here she is trying to help him to which gate he has to go. So she knows that the international passenger should go to international terminal. So that rule, um, so it decides which terminal or gate to direct passengers to. Backend pool, terminal gates are nothing but the backend pools. Servers handling different destinations. HTTP settings are nothing but rules on how passengers move. So this is rules on how passengers move, bus or walkway, etc. To the gate how they want to go from the information desk, bus or walk. Health probe is nothing but airport security, ensuring gates are functional. Front end, and here is a listener, and a bunch of rules are there, and the backend pool. And health probe is keep on checking whether the backend pool servers are up and running. Summary. So front end is entry point, detects requests, decide routing, backend pull destination servers, communication details, health pro monitors health. Together they make application gateway a smart, secure, and dynamic traffic manager. So let me give you a demo on application gateway. So here I have taken it from one of the Microsoft website, and you can also uh, practice going through this. Let me log into my portal.
Oh, it has a step-by-step process to configure.
Yeah, it has.
Okay.
So here first what he is trying to do, he is trying to configure application gateway, and here he is
Create a
trying
virtual subnet.
VNet for the backend pool, and front end IP is configuring routing rules, and backend settings is configuring application gateway. He is creating application gateway. This is the configuration part where he is binding the front end, the back end, and the routing rule. So the front end public IP, back end pool, and here the routing rule. That
Routing
means,
rules.
yeah, so whatever the request is coming to this front end IP, it has to go this. So that rule he will add here, and at the end he will configure. And for lab purpose, what we need to do is the backend pool should have the VMs. So he will configure those VMs. He will install IIS for testing. So basically, once the VM is created, he will run this PowerShell script. And basically, inetpub is the place where we keep our websites and all right for hosting on the IIS server. And inside this default HTTP default.htm is keeping value of that server name. So this will return, this is slash $env computer name. So generally this will give your computer name, like, one second. So if I say this, this will give my host name. Yeah, I don't think it is working. This is MacBook, right? So generally, if you try it on your Windows machine, it will come out. Here it will be host name. Okay, and this is basically that, which will give you the name of your VM. Anyhow, in the lab, we will be doing. Okay, at the end, he's adding those VMs to the backend pool. What I will do first is I will go ahead and create these VMs, okay, and configure them. First thing first, before we create a VM, we need to create a VNet. Mm, and this will be our techlines hyphen dev hyphen rg, and virtual machine VNet name is VNet1 East US next. I don't think I need Bastion now. IP address. This is one thing we need to make sure. One is we should have a gateway subnet. Gateway subnet, and yeah, I'm okay with the 10.0.1.0. Okay, I'll say add, and I will rename this to backend pool. Let's see. So whatever the VMs are there, I will add those VMs here. And when I create
Mhm.
the gateway, right, I will choose this subnet. Tags and next. Okay, the VNet is ready. Now I'll go ahead and create virtual machines, and I'll say VM1, East US, availability zone, no infra, standard. I'll keep this as a Windows Server 2016 data center. And I will not make any changes. Password, I will say I'll use admin user, then okay, in networking part, I make sure I'm choosing the backend pool subnet. I don't need public IP and everything as it is. Here also directly you can choose your application gateway. If you select this, it will ask which application gateway you want to add. Now that we don't have any application gateway created, it is not showing in the list. Or else we can directly add this to the backend pool of application gateway. Okay, I will say none. Next, management, monitoring, advanced, review and create. Clicked on create. I'll go back and create another VM. Okay, it has started. And the other VM2, I'll say, and let me reload. Actually, I was expecting it will populate the region.
Mhm.
It was showing empty, right? Mm,
Yeah.
VM2. And I will use Windows Server data center, and I'll keep everything as it is, and admin user p at the rate SSWRD 123. We need to change the VNet and subnet. We don't need public IP. And okay, I'll click on review and create. We don't need to change anything else. So what we have done so far is, so this is the link to the quick guide where we can create the application gateway. So this is the diagram, okay? And we created a VNet, and we created a resource group, and we created a backend subnet, and application gateway subnet we have created. We created two VMs. So that is what we have done so far. So we are yet to create the gateway and add the you know add the front end and back end pool and listener rules and everything. So there is one more step. We need to configure virtual machines. We need to install IIS for testing. So this
Testing
command,
the website. Yeah.
yeah, so this command does everything. So how we can run this is, we'll go back to this one. Here you need to change, see, the one thing you need to change your resource group,
Resource
and
group name with our name.
yeah, and also the VM name. Everything else will remain same. The extension name is IIS, publisher is Microsoft.compute, custom script extension. This is a setting command. So this command to execute is, it will open PowerShell and it will run this feature, web server feature, and it will add a content to this path, and the content value is this computer name. So I have already, this is already updated. Okay, I will take this and I will first run it on VM1. Control C, copied. So I need to run it.
We need to connect to your Azure portal first, right? Did you connect it?
One thing is we can run it from here, from Azure
Yeah, or
portal.
from Bastion.
Yeah, from Bastion we can connect, but here we did not configure Bastion. When we created VNet, we did not create Bastion. The other
Yeah.
way around is you can use the shell. So once you click on this icon, so this opens a shell. So this is a inline command tool where you don't need to authenticate again. You are already logged in here, right? You are on the
Yes.
browser. You are already logged in. So it will directly connect to this to your portal. So it is now authenticating. So now I am in. So I will go ahead and paste that command. Okay, so I'll go ahead and run it. So this will make changes on VM1, which is inside this resource group. Similarly, I need to run this for VM2. I will keep the command ready. It will take some time. So I'll go back. Meanwhile, this gets configured. I'll go ahead and create application gateway. So I'm coming to application gateway here. I'll minimize this. And resource group. And application gateway is, I will say your org name hyphen application gateway and the region standard, everything I will keep same. And virtual network, you need to select your virtual network here. Mine is VNet 1, then choose a gateway subnet. So what happens when you choose this gateway subnet and this gateway subnet will have the NSG rules, right? That NSG rule, in that NSG rule, we should enable access to the internet so that the requests going out or coming in should have access to the internet. Everything else like the backend pool or some other subnets are there, right? For them, you can restrict internet access because they don't need internet access. They have to, all the requests of those backend pools should go through this gateway. So, but this gateway subnet, um, the the traffic, right? It should have access to the internet because this is um, this should be get this is the front end part or the from where the traffic the requests are flowing in. So that's the reason we will keep a gateway subnet and choose public IP. So we need one public IP for the front end. I will say gateway public IP. Okay. Backend, add backend pool and backend pool application gateway hyphen backend pool and IPs. I will say these are virtual machines, VM1 and virtual machines, VM2, add. So this is a backend pool. Next configuration. So you have configured front end, you have configured backend. So this backend pool has both two VMs, and this front end is having the public IP. Now the request coming in from the pub to this front end IP should go to this backend IP. So this routing rule should be now configured. So this routing rule, hmm, gateway rule one and priority, I will say 100. So the listener name, okay, and this is, I'll say this is tech lines listener, your org listener, the name can be like that. And port, I will keep as it is, will not touch anything, and I'll go to the backend pool. Backend target is application gateway backend pool, and I don't think we have added anything related to backend settings. Let's add backend settings. This is B settings. Use backend port 80, and I will not use any of this. I will say add. So once this is done, create. So basically, this is what is done in this entire lab application gateway configuration. And once this is ready, we'll test. So I'll go back here and application gateway overview. So I got this public IP. I will copy this. Let me ping. I'm not getting any response yet, but once that application gateway is ready, it is still being configured. So once that is ready, yeah, I will start getting response from here, and I will be able to browse across the backend pool. One more thing is backend pools, backend settings. So you can use custom probe. You can check the backend health. That is the two of them will be added here, VM1 and VM2. So how do we check if there is a gateway timeout error or something? You come here and check whether both the backend pool endpoints are up and running. Let
Got it.
this, yeah, I think we also need to do one more thing. We ran this command for only VM1. We did not do anything on VM2, right?
For IIS. Yeah.
Yes, yeah. So we ran the command VM1, and it has made the changes. Now let's run for VM2. And I can press home. Okay, that's all it. So now this will install IIS and it will configure the website, the basic default website. Everything you can see here, like the rules which we have created. You can see gateway rule. This is a gateway rule. Uh, the listener name is this. The listeners, again, if you go and click on listener, you can see the listener and what is the IP also you can see. So the backend pool we have configured. So those details are here, the backend settings and the backend pool name. The rule name is this. And health probes. I don't think we configured anything here. We can configure this also. This will check, it will send the heartbeats and make sure that, the endpoints are healthy. This is the front end IP configuration. So this backend pool has one associated rule. So this has all the configuration related to that. So web application firewall is one other thing where you can configure like which ports to be allowed, which URLs to be allowed. All these things we can configure. WAF v2 policy name. This and all we can configure from here. Web application firewall. This is apart from the regular firewall or the VC. This web WAF is configured to this application gateway only. So which
Okay.
traffic you want to allow, which traffic you don't want to allow, that kind of configuration you can do on WAF. Okay, I'm waiting for this to complete. If you see this load balancing content delivery, there are four things. So this is one of the interview question. So for networking, there are four of them which you want to configure when you want to control traffic. What are they? They will ask. So you have to tell these names. Application gateway is one, load balancer is one, Azure front door, traffic manager. These four.
That's cool. Okay.
This is one of the question they asked me when I was giving interview in Swiss Re, and they
Okay.
asked me to explain what is application gateway. Even if you are able to talk on that, I mean at least to differentiate. So you can tell, okay, application gateway works at layer 7, load balancer works at layer 4, and load balancer will support only VMs and VMSs in the backend pool. But application gateway is not like that. It will support VMs, it will support app services, Kubernetes and all. And traffic manager is a regional one. Okay, it will distribute the traffic between the regions. And front door is something related to CDN. We'll cover these two tomorrow. Kind of a cache thing, CDN and all. Earlier there was a CDN option. Did you heard about CDN?
No.
Content Delivery Network.
Content delivery. No, I never heard about it.
Okay, so that was there earlier. Then they kind of add renamed or added additional features to that, and now it is called Azure Front Door.
Okay.
This traffic manager is there from a very long time. I used it like in 2016 or so, so like 9-10 years. This is a,
Yeah, the
this is
front door I also heard, but I haven't configured, but I heard about it.
okay. So now if we see, I'm getting response. Okay,
Yeah.
I think the application is up. What I will do, I'll try to browse with the public IP address. Go here, click on overview. I think from there, I think I will get the public IP. This is the public IP. So now you see here, this is the VM1. So if I refresh it, so sometimes the request may go to VM2 also.
Yeah, depends on the load. It automatically move. I
Yeah, yeah, it moved to VM2. So that's how it works. And to this IP address, you can create a custom domain name and you can add the DNS records and everything, right? Then you don't need to use this IP address directly. You can use the domain name. I think that you are aware, right?
Yeah.
Yeah. Okay, so this is how the application gateway is works, and path-based routing is something. So this is not part of that lab, but not part of the lab which is mentioned here, but something you can actually configure. It will allow us to configure somewhere in. Let me check. Backend pool rules. It is not here. I don't think it will be here. Backend settings. So basically, once while configuring it, it will show you somewhere that you can also configure the path-based routing. The slash images, you can keep the backend pool one. Slash videos, you can keep a backend pool two, like that. Here we have only one backend pool, so we did not configure anything. But now that this works at layer 7, right? When you are keeping URL, like as I mentioned, um, we have inserted the public IP, right? So then you use a custom domain, then slash images, then it will go to that pool. So so that's how it works, right? So that kind of configuration can be done in the path-based routing, like this. So that also just one more additional rule. Slash video should go to this pool, and slash images should go to this pool. That kind of configuration will be there, and it is easily configurable, not that hard. Just so I couldn't show that in this lab, but something you can try, or if you have application gateway used in your organization, you can check around, how that is configured. Just in these backend settings, and somewhere you can easily find it.
I'll try to have a look.
Yeah. That's all for the day, Amar. Any questions or anything before we close?
No, I'm good.
Yeah. Thank you, Amar. Thanks for your time. Bye.
Bye. Have a good day.
You too.